Welcome back. In our first video, we discussed that at its core, a network is simply two or more devices talking to one another. The internet is global and can seem complex, but fundamentally, it's just devices communicating. Today, we are going to talk about the OSI model, which stands for Open Systems Interconnection. As networks grew, the International Organization for Standardization, or ISO, developed this framework to provide a common basis and standard so diverse technologies could seamlessly communicate. Every network engineer uses the OSI model as an abstract framework to understand how data moves. It is divided into 7 layers, and when troubleshooting, we typically work from bottom up. To remember the layers in this order, I like to use the analogy, please do not throw sausage pizza away. Let's break down what each layer does. Starting with layer 1, we have the physical layer, the please in the analogy. This is the bottom layer where everything starts. The physical layer is responsible for the transmission and reception of unstructured raw bits streamed over physical medium. It converts digital bits, zeros and ones, into electrical, radio, or optic signals. This layer includes your physical hardware like cables, Ethernet or fiber, hubs, network interface cards, switches, and note, while you physically plug into routers and switches, their actual network logic happens at higher levels. For troubleshooting, if you're having an issue, always start by checking here for loose, unplugged, or damaged cables. For security purposes, physical security is paramount here. Threats include inadequate power, environmental damage, or unauthorized users plugging into wall ports. Then we move into layer 2, the data link layer. Do in the analogy. As we move up to layer 2, those raw bits are grouped into frames. This layer provides node-to-node data transfer and is divided into 2 sublayers, the media access control, MAC, layer, and logical link control, LLC layer. Here, we are introduced to MAC address, a unique hardware identifier assigned to every network-compatible device. The layer 2 switches operate here. Forward frames based on those MAC addresses to ensure data reaches the specific device on the local network. When you're troubleshooting here, a common layer 2 issue includes duplex and speed mismatches or broadcast storms. From a security standpoint, attackers can exploit this layer by using MAC flooding or ARP spoofing to intercept data. Moving up to layer 3, the network layer, or NOT in the analogy. Layer 3 is where we start moving data across multiple networks, a process known as routing. Here, frames are converted into packets, or datagrams. This is the layer where IP addresses live. Routers and layer 3 switches use IP addresses and routing protocols such as OSPF and BGP to determine the best path to send packets across the globe. From a security standpoint, we protect this layer using firewalls, access control lists, and IPsec to block unauthorized access and prevent attacks like SID floods, which we'll talk about more later. At the layer 4 level, which is the transport layer, or for our analogy, Thoreau, layer 4 focuses on reliable end-to-end transmission, breaking data down into segments. It manages flow control, error control, and sequence acknowledgement. It primarily uses 2 protocols, TCP, Transmission Control Protocol. TCP is a connection-oriented and reliable. It uses three-way handshake to establish a connection and requires retransmitting any lost packets to ensure perfect delivery. UDP, or User Datagram Protocol. UDP is a connectionless and sends data without verifying if the packet ever arrived. This is perfect for streaming video or VoIP, voice over IP, where a few drop packets won't ruin the experience, but waiting for retransmissions would cause terrible lag. Layer 4 also uses port numbers to ensure data goes to the correct application, like port 80 for HTTP or 443 for HTTPS. Troubleshooting. Issues here often involve firewalls blocking specific ports necessary for applications to communicate. Next, we have layer 5, the session layer, sausage. Once a connection is established, layer 5 manages the session or dialogue between 2 computers. It is responsible for setting up, maintaining, checkpointing, and tearing down connections. It dictates whether communication is full duplex, talking both ways simultaneously, or half duplex. Security. Common threats at this layer include unauthorized login access and exploits targeting protocols like NetBIOS and RPC. Layer 6, the presentation layer, or in our analogy, pizza. Layer 6 is often called the syntax layer. It formats and translates data so the application layer can understand it. When data is sent, the presentation layer handles converting formats, compressing the data to save bandwidth, and most importantly, encrypting. When data is received, this layer is responsible for uncompressing and decrypting it. From a security standpoint, protocols like SSL and TLS operate here to ensure encrypted, secure communication over the internet. Layer 7 is the application layer. Away in our analogy. Finally, we reach the top layer. This layer serves as a direct window for users and application processes to access the network services. While it doesn't represent the software application itself, like Google Chrome, it includes the communication protocols those applications rely on, such as HTTP for web browsing, FTP for file transfer, and SMTP for email. Security. Because this layer is closest to the user, it is heavily targeted by viruses, worms, and cross-site scripting attacks, requiring robust input validation and antivirus. How data actually moves. Encapsulation, sending. Data moves down the stack. Each layer adds its own header. Decapsulation, receiving. Data moves up the stack. Each layer strips off its header to read the instruction. To summarize, data communication relies on two vital processes: encapsulation and decapsulation. When you send a message, it moves down the layers, with each layer wrapping the data in its own specific header, like putting a letter in an envelope, adding an address, and putting it in the mail truck. When the destination receives it, the data moves back up the layers, unwrapping those headers at each stop until the original message is delivered. The OSI is the ultimate troubleshooting checklist. Always evaluate the type of issue you're seeing and work your way up. In our upcoming videos, we will do a deep dive into these concepts, using tools like Packet Tracer and Wireshark so you can see exactly what these packets and conversations look like. Thanks for watching.